In this lesson, we're going to learn how to determine the equation of a circle, which, remember from previous lessons we've learned, has the standard form that goes like this. Okay, so we're going to learn how to do that when they have given us the center and the tangent. So a tangent, let's quickly talk about what that is. If you have a circle, then a tangent is a line that touches the circle in one place. So for example, that wasn't a tangent. Oopsie. So something like that, where it touches in exactly one place. So here's our first example. It says that we have a circle which has a center at -6 and 5. So I don't think we need to really plot it, but let's do it anyways, just to try and get a better visualization of where this is. So -6 and 5, let's say that that's about there. And we've got the circle. Now, we don't know if the circle looks like that, or like that, or, you know, we don't really know. But we sort of can get an idea, because they tell us that the tangent is the x-axis. So this is the tangent. So that means the circle needs to come along the bottom like this. So it would be something like that, where it just touches the x-axis in one place. Now that's not a really nice circle. Let me try a little bit better. So maybe up to there, and something like that. Okay, that's more like an ellipse, but you get the idea that it can't go past the x-axis, because they said the x-axis is a tangent, and a tangent can only touch the circle in exactly, or like just on the outside like that. So the circle would have to do something like that. Okay, so that's sort of the idea that we have here. Now the center is at -6 and 5. So what we can immediately tell is that the radius, we could work that distance out to the radius. Or sorry, from the center to the tangent. We could know that that distance, because this point over here, well, actually there's something else I need to tell you. Maybe your teacher hasn't mentioned this. Did you know that a radius and a tangent are always perpendicular? They're always perpendicular to each other. So let's actually say here, they are always perpendicular. Now, I don't know why I said that so weirdly. Perpendicular. So perpendicular. Okay. So if we draw this going straight down, then we know that these two lines, the tangent and the radius, they're perpendicular. So this purple line is completely horizontal, because it's an x-axis. So that means this line must be perfectly vertical, because that is the only way. If you have a horizontal line, then the other line must be perfectly vertical for them to make 90 degrees. Why do they make 90 degrees? Because we said they are perpendicular. So the reason that that is important is that because this line over here is completely vertical, it means that the x value over here and the x value over here would be exactly the same, because the line doesn't go a little bit to the right, left, or a little bit to the right. So the x value would be -6. Then the y value we know would be 0, because it's on the x-axis, and the y value on the x-axis would always be 0. So what we can then realize is that the radius length can easily be obtained as 5, because to go from 0 to 5, that is just 5. So we have the radius, and we have the center, so we can easily write out the circle equation. So let's first go write out the standard form. So we know that if the circle center has gone 6 to the left, then left means plus, so you'd put a +6 over here. And if the circle center has gone 5 units up from where it would have started at the origin over here, then that means minus. Up means minus, okay? And we've spoken about this in the first lesson that we did on circles. And then the radius is 5, so we'll square that, and so we should end up with 5 squared, which is 25, and that would be the final answer. Now we're just going to do one more example. So here they've given us a circle, so let's go draw it out, just so we can get a better idea of what it looks like. So the center is at 3 and -2, so that would be somewhere over there, for example. 3 and -2. Now we don't know if the circle looks like that, or if it's a little circle, but what they've told us is that the y-axis, which is this one over here, that is the tangent. So that means the circle cannot look like that, because a tangent cannot go through the circle like that. a tangent has to touch on the outside. So that means the circle is going to come something like, it's going to do something like that. So let's put a little dot there. Now look at that distance. That's the radius. So we can do that on all four sides just to get a good, just to try and get a nice idea of what the circle would look like. So maybe there, and then maybe there. And so then if we have to go connect all of that, just to get a nice, ooh, Kevin, that is not great. Something like that. So that's what the circle would look like. So we can then realize that this line is completely, or let's first start with this line. This line here is completely vertical. Why? Because it's the y-axis. So it's completely vertical. That means that the radius, this radius over here, would be completely horizontal. Why? Because we learned in the previous example that a tangent and a radius are always 90 degrees to each other. So this is completely horizontal, this line. So because that line is horizontal, then I know that the y value over here would be -2. Because this y value is -2, and this y value would also be -2 because it has not changed up or down. It stays on the same level, okay? Because it's on the same level, the y value wouldn't change. We also know that this is on the y-axis, so the x value would have to be 0. So that would be the coordinates over here. So now we know the coordinates of where the tangent is touching over there, and we also know the tangent of the center. So we could easily find out this horizontal distance would be 3, because it's going from 0 to 3. So the radius is 3. So now we can go and work out the equation. So we know that the basic equation is like that. So if we look at the circle center, if you think about the origin, which is over here, it's moved 3 places to the right. So right means minus, and it's moved 2 places down. Now down means plus. Okay? And then the radius is 3, but 3 squared is 9. And so that would be the final answer for that one.